on, maybe I'll answer them today, maybe I'll answer them next time, but we can start with questions. So, how do you go? I heard lots of good conversation going on, so there must be some questions. Yeah, Matthew.
How do you get like your Disco code to run on Disco? Like if you're loading it through a text editor, like if you press like load whatever something .disco, how do you get like not just the scripts to print, but like everything, like it would be typing it in Disco? Does that make sense?
So, how do you get? So you mean like? I'm not sure I understand. So
like if you wrote something in like I don't know, just like true and true,
right?
In Disco, it would print true. But if you wrote that in text editor and like loaded it, then like just the tests print. You don't actually see.
Oh, you don't actually, it doesn't print out true. Okay. I see what you're saying. Yeah. Expressions. Okay, other questions? I'm really tempted to just like answer my question right away, but no, I'm not going to do that. Let's make a big list. Doesn't matter if you think it's a silly question.
How can you make it load so that it just does, you can just type in load Disco and you don't have to necessarily indicate the pathway? Is there a way to change that?
Okay, I see. Type in the whole path. Is that your question? Like instead of typing load, C:, blah,
Right.
blah, blah, right? Okay, good question. Other questions? Olivia? Okay, so how to define functions and how I can run them and see output. Okay, other questions? Yeah, Olivia.
All the symbols that we're using, like how to take them from what we see, like when I click on A and things like.
Oh, okay. You actually went on, okay. And some of these questions maybe don't have good answers right now, but it's helpful for me even just knowing what questions you have, because I'm like, oh, yeah, I didn't realize that people would, it just didn't occur to me that someone would have that question, but now that you ask it, I'm like, oh, maybe I should go like change something or, make some documentation or whatever. So, any other questions? You said like, for example, yeah, so you just go into Disco's like handwriting recognition mode and you just like write it. No, that would be a whole PhD unto itself. Anything else? All right, well, obviously, if you've got more questions, you can ask at any time. So, my plan is, and we'll see how it goes. We'll just see how quickly or not quickly we go through this. But the plan, at least, is to spend the rest of the week just focusing more on, like, we've been using Disco kind of just to illustrate what we've been learning and to play with stuff. But I want to spend some time exploring Disco, like, as a programming language itself and how we would So, so let's start, I can answer these two questions together, I think. And we'll just do a couple examples. We've done some examples, but, so the way, and this is something, I think I didn't do a very good job of explaining this originally. And I know some people have struggled with this, and I've helped some people figure this out. Other people maybe haven't figured it out. When you run a program from the command prompt, it doesn't matter whether you're on Mac, Windows, Linux, whatever. If you open a command prompt and run a program, there's always an idea of like what's your current directory or the current folder that you're in. And sometimes the command prompt will like print out the current folder. You know, we'll say like C:" something, or it'll say, it depends on what operating system and exactly how your command prompt works. But whatever it's showing, it has an idea of like the current folder that it is in right now. And when you run a program, that program kind of inherits that, and the program says, okay, this is the folder that I'm kind of in. And so if you then tell that program to look for a certain file, that's where it's going to look. Okay, so if you have a file over here that you want to load, but you start the program over here in some different folder, then well, you're going to have to tell it the exact location of that other file by saying that the whole path, right? But if you go into the same folder where you have that file and then start the program, then you can just, so let me just illustrate this. So if I go out here, so let's say, I'm going to make, okay. So let's say, so this is, so, I mean, this probably looks a little different than whatever your command prompt looks like. So I'm on Linux, but the principle is going to be similar. So this is showing me, well, the current folder, I have a folder called teaching. Inside of that, I have a folder called M240. Inside of that, I have a folder called disco. And if I create a file in here, you know, and notice I use this command called cd to change what folder I'm in. And that same thing works on Mac OS. I actually don't know about like the Windows command prompt. I think it might have a, no, I think actually cd works there too. Yeah, I'm getting some nods. Okay, it's exactly the same command. So cd stands for change directory. If you haven't seen this before. So let's create a disco file in here. I'm using the editor that I like to use, but you use whatever editor you're using, right? Let's make a function. What function do you want to make? Let's do like, let's do a function that's rational. F of R equals R squared divided by 6. So I save that. So now, you know, if I'm just anywhere, so I just went back to the top like home directory. If I start disco, if I try to say load example.disco, it's gonna say it can't find it because it's looking in the directory where I started it, and I started it in just like the top level, my home directory. So I can't find it, right? And I could say, you know, in my case, I have to say something like home friend. Right? That'll work. And I think this is what, was it Adam that asked, like, how do you not have to do this, right? Because that's super annoying to type out that whole long thing. And for you, maybe you have to say something like C:\\, you know, whatever, or if you're, depending on what operating system you're on, right? So if I instead use the cd command, I first make sure I am in that same directory where I have my disco file. And then if I run disco, so I can run it just by typing disco. You might run it by typing like C:\, /bin/disco or something, or I don't remember what it is on Mac OS, but now I should be able to just say load example.disco, and it'll load it, because it's looking for it right there in that same directory. Does this make sense? Does that answer your question, Adam?
Yep, absolutely.
Yep. And so, right, I think, I know some people, like, kind of figured out that if they put their disco files in that like c:\cabal bin directory, like where the disco.exe lives, then they could start disco.exe from there and it would find them. I mean, you can do that. I don't recommend that because that's kind of like the place where the disco.exe lives. You probably want to make a folder somewhere, just wherever you keep your files for school, just make a folder somewhere called disco or called discrete math or whatever. And you can keep your .disco files there, and then go and start disco from there. All right. So, and someone asked about just seeing more examples of defining functions, right? So, and we'll see more examples today of other ways to define functions, but this is the very simplest way. There's two parts. I have to say what type it is. So in this case, I said that f is a function from rational numbers to rational numbers, and then I give a definition. In this case, I say f of r squared divided by 7. And then once I've loaded this, right, did you all figure out about the names command? Probably not. So there's a help command that tells you a bunch of things you can do. We've definitely used, we've used load, and we've used, I think I've showed you doc. Right? That shows you documentation on things. There's other stuff, and you can play with these if you want. Oh, we've seen test, right? Names just prints out a list of everything that's currently defined. So this can be helpful to be like, okay, what do I even have that's loaded that I could use? So right now it says, well, the only thing you have is f, right? We loaded that from the disco file, so I could use it. I could say, okay, what's f of 3/5? And it'll tell me, right? So I can play with f. I can try it on examples, and use it in bigger expressions, whatever I want. Okay, cool. Again, something that maybe you've probably seen on the modules, but maybe we haven't talked about explicitly. So if you put 2 dashes, this is how you make a comment. So disco will completely ignore any line that starts with 2 dashes. Disco will totally ignore this. Okay, so if you want to put in a message for yourself or a message for me or a reminder of what something is, you can put that. Grace?
Why did you choose something like 2 dashes rather than the slashes?
Good question. Dashes is what is used in a language called Haskell, which in many ways is a more similar language to Disco than, say, Java. But, I mean, ultimately it doesn't really, every language has different syntax for comments. And then it's one of those things you're like, okay, now I know I know 3 languages and I know 5 syntaxes for comments, so I have to remember which one am I using. Yeah, but there was no deeply thought out reason for that. That was just something I was familiar with. Okay, but we've also seen another kind of comment in Disco, which is where you have the triple bar thing. So this is documentation. Okay, so Disco doesn't ignore this. It is like a comment in the sense that it's not code, but when you put it right before a definition, Disco will remember that, and it goes along with that thing. So later, if we ask for documentation on F, it'll show us this. Okay, so you reload, which I can say, we saw there's this :reload command. You can also abbreviate commands as long as it's you can say :L or you can say :R, as long as it's unique, as long as it's not ambiguous which command you're using, you don't have to put the whole thing. So I can just say :R reload. And now if I ask for documentation about F, right, it tells me the type and it also tells us that documentation is done. You can use this or not as you wish. It's up to you, right? I mean, I'm not going to require you to put documentation on these things, but certainly especially when we start learning about, like, there's some standard functions that are defined in a library for you, and they all have documentation, so you can, if you want to know more about them, you can ask. And then, I guess it's kind of like a comment, sort of-ish, like the 3 exclamation points, right? This is how you write down a property. And it is actually code, right? But it's code that kind of is attached to a certain definition, and it specifies some kind of property that should be true, right? So maybe like, you know, F, for all rational numbers Q, FQ is greater than or equals to 0. I think that's true, actually, since we're squaring it. Right, and we've seen that every time you load it, it'll test those properties and make sure that Disco thinks those are true. Right? So, load is a property. Right. And you can put blank lines, it doesn't really care. You can even like, I think, you can like intersperse. You can have like some documentation and like another property, you know, say like, you know, apple. So number 5, no, 25. So reload. This is okay. The test passed, and if I ask for documentation about F, I guess you can't do that. Oh. All right. Because it didn't say below the property. So you can do this. Maybe I should fix that. Okay. Cool. Any questions so far? Thanks. So a few times I saw people like trying to use this like triple exclamation point like thing inside of a definition of a function because they like wanted it to have a certain property. I mean, this is the only place you can put the triple exclamation point thing is like before a definition. It's not part of a definition. It's just like an extra thing you're attaching to the definition. And you certainly are welcome to make these yourself. And a few of you have done so. Most haven't, but if you're writing a function, it's always a good idea to write down, at least you can write down some examples, right? You're like, well, I know what this function should do on, you know, 1, 2, and 3. I could write those down as examples, and then just to make sure that I define it correctly. Like even when I was, what was it? I think when I was developing the module for last week, I was writing some Disco code, and I wrote something that like, it was a really obvious function. It was like, clearly this is how it's defined. I'll just write down a property just to like say what property it should have, even though I know of course it has that property. And then I loaded it, and it said it was false, and I was like, what? And then I realized I had like switched false to true. I had them backwards. And I was like, oh, duh, yeah, okay, great. So it actually like caught a bug because even though I thought it was obvious, I wrote down the property anyway, and it said, nope, here's a counterexample. So, all right. So let's see, what was the other? Okay, so how to write symbols. There's not like a great answer to this because, you know, like if you're just looking at this symbol, for example, if you don't know what it's called, then it's going to be hard for you to figure out how to enter it into Disco, right? Because it's not on the keyboard, and you can't Google it because you don't know what it's called, right? So at some point, you have to know what it's called. And if you see a symbol and you don't remember what it is, then ask me or ask someone else in the class, like, can you remind me what this symbol is? I don't even remember what it's called. Okay, once you know what it's called, you could, so there's 2 things you could do. Number 1, you can Google it and find, you know, somewhere you can copy paste the Unicode for that symbol. So for example, we could do that with for all here. If I just Google like for all Unicode, right, here it is. I don't even know what website this is, but whatever. Unicode character for all. Copy. And I can go back to Disco, and here, instead of typing the word for all, I can paste that in, and that should work. Okay, so you can only do that. And so the goal is, this is not like 100% true, but I'm trying to make it as true as possible. Every symbol that we use in class, you can use in Disco, like there's a Unicode version of it that you can use. And also, there's a version that just uses plain text that you can use as well. So you don't have to copy paste any funny symbols if you don't want to. So this is a good example. So we can actually use that symbol that we use, or you can type the word for all. Now, how do you know like what word you have to type instead of using a symbol? Well, you just have to, if you don't remember, you can look back at the lecture where I talked about it, or you can look in the Disco documentation. And this is something that maybe I can improve. Maybe have like a table. I think I'm going to do this. Make a table on some, on some page that's like, here's a list of all the symbols and their corresponding, things you can type instead of using that symbol, right? That might help. Cool. And then there's one other question. How do you get expressions in a .disco file to print? Oh, that's a good question. So I kind of thought that they did, but I might be wrong. And so if I'm wrong, then I guess I need to fix it. So if I just type like 3 plus 2, or you do the example of like true and true. Right, if I reload this, okay, I was wrong. So that's something I'll have to fix. Because, yeah, my intention is that, so it certainly lets you do this, right? It lets you put things in here like this. It is, in fact, checking them. So like if I, for example, if I misspelled true and I tried to load it, it says, oh, there's nothing named TRU. So it is actually like checking it and making sure at least that it makes sense. And I think it's even running it, but then it just doesn't print out the answer, which is kind of silly. So that's just something I'll have to fix. And thank you for pointing that out. So these don't get printed right now, but they will soon. And literally, like, they might this afternoon, because it's going to take me like 5 minutes to fix that probably. One other thing I wanted to show you that I did change recently, so you might want to update Disco. So let me do another thing here. So -5. Okay. So this is not allowed, and we'll talk more about this in just a minute. But basically, since this function is on natural numbers, subtraction doesn't make sense on natural numbers because, like, what's 2 minus 5? It's not a natural number, right? So Disco does not like this, and it won't let you do subtraction when you're dealing with natural numbers. Now, sometimes you really want this, and we'll talk about how do you get around this when you want it. My point, just for right now, is that this definition will not be accepted, and it'll give an error. And before, it would have said type checking failed. It still says that, except now it tells you which function type checking failed in, which is way more helpful than just saying like something in your whole file is wrong, right? At least it's like, it's in this function, that's something is wrong. Okay, so if I reload this, it says, while checking example.g, okay, so this is the name of the file, and then the .g means, in the definition of G, type checking failed. So it still doesn't really tell you what's wrong, but at least it tells you which thing to look at. And so this is something I wanted to, so hopefully this will help. I also wanted to point out that sometimes I see people turning in things where like they have a whole bunch of stuff defined in a Disco file, and it just like it has an error. And if you don't know where the error is, one thing you can do, right? If you weren't sure, you could like, if you comment out some part of it, then now it's like not going to check that, and I can be like, okay, I just want to know, is my F correct? I know there's a problem with G, I don't know what it is, but at least I can put G in a comment, and now I can reload it. Oh, I didn't actually save it, okay. Okay, at least now I know that F is correct, right? So I can work on F and make sure it's working, even though I have this other thing that's not working. So you should definitely try to use that technique, because sometimes I see students, like, they're confused about something, they can't get it to work, but they're like, well, I just need to go on and like try working on the rest of it. And so they'll write a bunch of stuff, but they can't actually use Disco to check it because it's just saying there's an error with the first thing, right? But at least you can put it in a comment You should always try to, you know, load whatever you have into Disco and make sure that it's working, and try it bit by bit so that you know each little piece, whatever it is, okay? We can make that. All right, so I think that was all the questions that people asked there. Were there any other questions of anything that I've said so far I could kind of start with you, Adora?
Are you able to declare a function within the same line that you described it, I guess? Let's say he is a natural number to a natural number, and that's equal to x plus 5.
No.
Okay.
No, no, I don't, like something like this. Yeah, no, you, no. Yeah. Good question. It would certainly be possible to add that. I'm probably not going to because I think there's other things that would be higher priority, but certainly would be a nice feature. And notice you can actually, so even though like a function, defining a function takes multiple lines, you can in fact define a function, for example, just in the REPL. So if I said, you know, like arrow n, I can just hit enter, and it's like, okay, you're telling me that q is something of type n arrow n. I'll remember that, and you know, now it's waiting for me to define it basically. So now if I say, you know, q of list 17, right? So now, right, q is defined also. So now. Sometimes it's useful just to define something, right? Just if you're playing around with something, you're like, let me just try this. Or I need an example function to use for something, so let me just define it really quick here, and then I can use it. You don't have to necessarily put it in a file. So, Mason, you have your hand up?
Yeah, I had a couple of questions. So with the not being able to subtract with the natural number function, with the x minus 5, could you set a property that made it where x can only be greater than or equal to 5, and then would that be allowed?
So, great question. So you're saying, could I somehow convince Disco to accept this if I promise it that like the x is always going to be greater than or equal to 5 or something like that? That's a great question, and no, you can't. The reason that you can't is that in general, like with that particular example, it's easy to kind of imagine how that would work, right? It's kind of keeping track of, okay, there's this range of where x can be, and if you subtract, I just need to make sure that it's greater than this, and then I'm okay. In general, if you start doing like more complicated things that involve subtraction, you might need kind of arbitrarily complex conditions to ensure that it's going to be okay. And it actually gets pretty complicated to figure out how do you automatically make sure that yes, this is going to be okay, or no, it's not. And so, yeah, it doesn't do that, or it doesn't allow you to do that. However, so yeah, let's. There's two things that we can do. Well, let's talk about this now. So this is not. So subtraction. There's two ways we could fix this if you really wanted this function. Okay. One way. So there's another operator called Dotminus. Okay. Dotminus is like subtraction, except that if the answer would be negative, it just gives you 0. So it's called saturated subtraction or truncated subtraction or something like that, right? So like 3 minus 2 is 1, 3 minus 3 is 0, 3 minus 4 is also 0, 3 minus 17 is 0, right? So it's not the same operation as subtraction, but it is defined on natural numbers, right? Because you just always get 0, you can't get anything less than 0. So I don't know if this is what we want or not, but it's one thing we can do, right? And this is, I mean, if you know, for example, you know, what if we said like, Right, so I think, you know, maybe this is kind of similar to what you were wondering, Mason. Like, would Disco accept this definition? Because look, we're first handling the case when the input is 0. And so if we get here, we know that the input is not 0. Because if the input was 0, it would have done this first case, right? And if it gets to here, it means the input is 1 or greater. And so in that case, we can actually reason that this is safe, right? This will always give us a natural number. But no, it still won't accept it. Disco isn't, like I said, in this case it's easy to reason about this, but the reasoning can actually get arbitrarily hard, and Disco's just like, no. Well, Disco, not for something like me. I said no, right? I'm not willing to program that. And not just because it's too hard, but actually because it's, in general, probably impossible. Like, and there's some cases where you literally can't figure out whether it's okay. So, this is a good example where we could just use Dotminus. And we're like, I know this is safe, so I'm just going to use Dotminus. In fact, it will never do the behavior where it has to return 0 instead of a negative, but Disco will now be happy with it, because it's like, okay, that's what I did. The other thing we could do, so, two solutions. And let's go back to the like -5 thing. I could say, you can actually do this. And basically what this says is, if the input looks like 5 more than something, then return that something. Now, as it stands right now, this function is not defined on, for example, 4. So it's not a fully defined function. But I could say, you know, like G2 of, I don't care, anything else, is equal to, you know, 77. Right? So this is saying, look, for anything that's 5 bigger than a natural number, just return that natural number. And so that's doing, it's doing -5, right? But only for things that are 5 or greater. Because if I give it 4, it checks this first, and it's like, nope, 4 doesn't match this, because 4 is not 5 more than a natural number. And then it would, in that case, go to this case and say, all right, well, 4 didn't match here, so we go to here, and now you don't care about the input, so return 77. So if I reload this, so G2 of, you know, 5 is 0, G2 of 6 is 1, but G2 of 4 is 77. So sometimes this kind of thing can also kind of do what you want. So you don't have to actually use subtraction, you kind of use a pattern that uses addition. Cool, other questions? Yeah.
So about the using symbols from Unicode.
Yeah.
I don't know if it's a Windows thing, but whenever I try it, like whenever I was type checking and stuff, it would put the symbol in there, and it would just give me like the box with the question.
Yeah, so that has to do with like, do you have the right fonts that have those characters in them, and also is your terminal, or is your, you know, your command prompt, whatever, set up to use the right fonts? I'm definitely happy to help you try to figure it out, but that's kind of it's a separate issue, right? It's not Disco's fault. It's like, just that either your computer doesn't have the right symbols to display to you, or it's not set up to be able to use them. It should still work. Like, Disco will still get the right, if you paste in one of those characters, Disco will still kind of see the right character. It's just that it's not being displayed to you, if that makes sense. Like, the character is there, it just doesn't know how to show it to you, so it's showing a box. So that's kind of annoying to look at boxes, because you can't tell what it is, right? So, all right. So I think I want to spend the rest of the time today talking a little more about, so we talked a little here about like natural numbers and subtraction and like, and we've seen that Disco doesn't only have natural numbers, it also has like integers, rational numbers and stuff. I want to talk a little bit more about that, because that leads into several interesting things. So, beginning, there were natural numbers, right? 0, 1, 2, 3. Aside from arguments about 0, I mean, 0 is a special, interesting butterfly. Probably when people started counting, well, we know, when people started counting, they typically did not include 0. They didn't have like a word for it, or they didn't think of it as a number. Maybe they had a word for it. It's like I have nothing, but they didn't think of it as a number. So it's an interesting history. Like, when did people start thinking of 0 as a number? And that concept arose in different places, in multiple times and places independently. Fascinating history. I'm not going to get into it right now. We're going to take 0 as a number. So what can you do on natural numbers? You can add them, and you can multiply them. Right? That's all you can do. So then we might say, well, we want to be able to like undo addition. If you like add 5, I'd like to be able to undo that and take the 5 back, right? Well, that's subtraction. Or you can think of it as adding the concept of negative numbers, right? So adding a negative number is just the same as undoing your addition. So if you do that, right, you get what we call the integers, right? So this is so going this way, you're adding subtraction or negatives, which is the inverse of addition. And maybe it's a little small. Okay, hopefully. I do actually mean inverse in the sense of like an inverse function, like a bijection. Although requires a little bit of fiddling to kind of like figure out the right way to view it, like what function are we actually talking about. But intuitively it's clear, like if you add 5 and then subtract 5, those cancel each other out and you get back to the same place that you started, right? So the other thing that this picture so far, I'm going to add more things up here, but the other thing that this highlights is that, right, we started with the natural numbers, and then we added some negative things to give us the integers, but like every natural number is also an integer. We didn't like lose anything, we just added something. And if you have a function that is expecting, that says it takes as input integers, its domain is integers, and you give it a natural number, that should be okay, right? Because every natural number is an integer. Now, different programming languages have different opinions about whether this is okay or not. But in math, like, if a mathematician defined a function that, on integers, and then, tried to give it 3, and you're like, oh, no, 3 is a natural number, but that function says it takes integers, so that's not allowed. They would look at you very funny, because they're like, but every natural number is an integer, so like, so actually, let me show you really quick. Let me switch back over. So do we have a int fun x minus 9? Sure. Okay. So and then I'm also going to define nat. 6. Okay. So int fun says it takes integers as input. Nat is defined to be a natural number. So what will happen if I try to give nat as an input to int fun? Some programming languages would yell at you and would say, and I'm not saying those languages are wrong. There's different reasons for choosing different things here. They would say, no, this function says it has to take an integer, and this is not an integer. It's a natural number, so it's the wrong kind of input. and you would get some kind of error, and you would have to like, maybe there'd be some kind of built-in conversion function you could call to convert a natural number into an integer, and you have to like convert it. Right? But Disco doesn't make that choice. Disco says no. Every natural number is an integer, so it's totally fine if you have something that's a natural number, you can pass it to this function that's expecting an integer, and so it works, and we get -3. You can think of it as it's kind of like converting the natural number into an integer for you, and then, but it doesn't. There's not really any conversion that has to happen because, like 6 is a valid integer, so it's totally fine. Okay, so this is called subtyping. So every n is also a z, so we can give nat as an input to info. So I can say okay. Right. Makes sense so far? Any questions? Okay, so then we have the integers, and we say, all right, that's nice. I can subtract now, but I still have this multiplication thing, and I can't undo that. So if I multiply by 7, I don't have any way to like undo that and unmultiply by 7. So obviously unmultiplying is division, right? So if we wanted to add that, well, we can add the division operation, but then we have to add fractions and stuff, because like what if you say 2 divided by 7? That's not an integer, but we can make up a thing that it is, and that's called 2/7. And so if we kind of add all possible fractions, then we can do division, right, and we get the rational numbers. So this is adding division slash fractions, right, which is the inverse of multiplication. So I should say here we can like do plus, times, and minus. And up here we can do, so this is like, 1/2, 3/7, -34 over 99, etc. And we can do all for kind of standard arithmetic operations on this thing. Right? And as you might expect, right, the integers is also a subtype of the rationals. Every integer is a rational number. So again, if I had a function that's expecting a rational number as input, I can give it an integer. Or I can give it a natural number. Right? That would be okay. I can't go the other way, right? If a function says it's expecting an integer, I can't give it a rational number. Because maybe the function is not defined for rational numbers. Or like, there's no guarantee that the rational number I give it is actually an integer. And so it's not willing to accept that. So the way I've drawn this maybe suggests there's something missing over here. So this is the way people usually talk about these sets. And so we start with naturals, and then we add the ability to subtract, we get integers, then we add the ability to divide, and we get the rational numbers. And maybe you've seen it presented this way. I don't know, maybe you've never thought about this at all. But what do you think? Like, what's missing over here? This would be like if we said, what if maybe the first thing I want to do is actually divide? I don't care about subtracting. I just want to be able to divide. Okay, if we just start with the natural numbers and we add the ability to do division, then we just get all positive fractions, right? We don't get negatives. And so Disco calls, there's no like standard mathematical name for this, but Disco calls this F for fractional, right? And this is things like, 1/2, 3/7, but not negative anything. And we can do addition, multiplication, and division, but not subtraction. So, let's see. notice I didn't draw like arrows over here, because it's the same arrow, right? Like, going that way, either from here or from here, going that way means adding division, and going this way means you're adding subtraction. And Disco can automatically figure this out. So if I just type in 3, it'll say, oh, that's a natural number. If I say 3 minus 5, it's like, oh, that must be an integer because you're doing subtraction. If I say 3 minus 5 divided by 8, it's like, oh, you're doing subtraction and you're doing division, so it has to be a rational number. And it'll just figure that out for you on how to do it. I will just mention quickly, but then probably next time we'll do more examples of this. You can also go, how do you go this way? So like this way is adding subtraction. How do you take it away? Like if you have negatives but you don't want negatives anymore, any ideas? How would you get rid of negatives if you don't want them? Garrett?
The absolute value.
Exactly, absolute value function. So you see, if you give the absolute value function an integer, you actually get back a natural number. Absolute value. And what about, I'm running out of space here, but if I want to undo adding fractions, any ideas? If I might have fractions and stuff, but I don't want them, I just want integers or whole numbers. How do I do that?
Try the denominator.
What was that?
Try the denominator.
Just get the denominator or something?
Yeah, just multiply the same number.
Oh, like cross multiplying or sort of, I see. Yeah, if I have like an equation and I want to get rid of fractions, I can do that to kind of turn it into an equivalent equation that only talks about natural. But if I just have a single number, like I have, 3/5, or I have 17.26 or something, and I don't want any fractional part, I just want an integer. Adam?
You multiply by the inverse.
Multiply by the inverse. What do you, oh, like, well, I'm not sure what you mean multiply by the inverse. And I just get 1, right?
Yeah.
Okay. Garrett?
Just get the numerator and one denominator.
Oh, you could do that, yeah. And there is a way to do that. That would work. The thing I was thinking of is rounding. So if you just like round to the nearest integer. So there's things called like floor and ceiling. We'll talk about that next time. Anyway, we're out of time. So see you all on Wednesday. Okay.